So here's the other method we have of solving systems of linear equations. And there's only two, well, besides graphing, well, there's only two algebraic ones. And what the goal is just to see, for you to know when it's going to be more conducive to use one or the other. So this is called elimination. And the only way to do this is to dive in and use examples. So we have x plus 2y equals 11 and negative x plus 5y equals 10. So notice these equations like line up nicely with the x's and the y's. And the key to this is we can, just so we can like add two numbers together, we can just add two equations together. So kind of bear with me. You'll see it when it happens. Since we have two things that are true. This equals this, and this equals this. If I add this and this, and I add this and this, the thing I get is still going to be equal. All right? So if I have A equals B and C equals D, then I can add A and C, and I can add B and D, and I get something that's still true because all that stuff was equal to begin with. So the way to add two equations, especially if they're nicely lined up like this, is to just like add them down, just like you would with two big numbers if you had to add them manually, vertically. Okay? So you take your x plus 2y equals 11, and you take your negative x plus 5y equals 10. Now everything's lined up. The x's are lined up with the x, the y's are lined up with the y's, and the constants are lined up with the constants. So just add everything. 11 plus 10 is 21. 2y plus 5y is 7y. X plus negative x is 0. And that's the key. We got rid of x. And another word for that is elimination. So we eliminated x because we had a negative x and a positive x. So this is also sometimes called the addition method. Some people may teach this to you where you can subtract the equations sometimes. I find it's easier just to say you're always adding them. So but one of them has to go away when you do that. And by one of them, I mean one of the variables. So in this one, we happen to just knock x out. That's the whole idea here. So now we just have 7y equals 21, which means y is 3. So you see how fast that was? So I generally like this method better, although sometimes it's a lot of work to even be able to get it like that. So both methods will work no matter what. But at some point, I do want to see that you can use both. Okay, y equals 3. And then once you get one of them, now we're kind of right back where we were before. You can just plug y equals 3 into either of the equations and figure out what x is. Okay, so once you do that big move, now you're just right back where you were before. So whichever equation we feel like using, I guess I used 1, so y is 3, so x plus 3 times 3 equals 11, which means x is 5. Right, and now don't stop, but again, it's the same thing. Now that, well, you have them both, right? So just put them in a concise place or put them as an ordered pair, 5, 3. And then it's very easy to check. You may even be able to check it in your head. Just make sure that if x is 5 and y is 3, then both of those original equations are satisfied. They are. So if it's like this, and we had an x and we had a negative x, so I'm calling those like matching coefficients with opposite signs. You could also call them additive inverses. So if you have an x and a negative x, or like a 10x and a negative 10x or whatever, those would be additive inverses. So if you see that, the elimination method is almost instantaneous. And if you think about doing the same thing with substitution, it would have worked. It just would have involved a lot more going on in this step. This step would have taken longer. As it is, this step was like instant. Okay. Obviously, we're not always going to have that, but we can still use elimination because we can always make coefficients sort of match each other and turn into whatever we want if we just multiply them by constants. And we can always do that to an equation as long as we do both sides. Okay, so solve equation 1 is 2x plus 6y equals 5. Equation 2 is negative 4x plus 3y equals 15. So we don't have, if we just added these together now, we'd get some third equation, but it wouldn't really be very helpful to us. So there's a couple different ways of doing this. So we need to get one of either the coefficient on x or the coefficients on y to be additive inverses of each other. And to me, the most obvious way to do that is this first equation. If you just go ahead and multiply it by 2. Why did I say 2? Well, because you're going to get a 4x here, and then it'll eliminate that negative 4x. Now this will become a 12y and this will become a 10, but that's fine. We have to eliminate one of the variables. Okay, so that's not the only way we could have done it. We could have done it a different way and still been right. So this to me was just the obvious way. I mean, namely, I guess if you took the second equation and multiplied it by negative 2, that would make this into a negative 6y, which would eliminate that. So that would work. You don't always have to do it exactly my way. Okay, so take equation 1, manipulate it like that. So we're going to get what? 4x plus 12y equals 10. And now stack them up. So right now it's like we're back to where we were in the previous problem. So sometimes you might have to do a little bit of groundwork first to make it eliminate. And again, this would always work. There's always going to be a way to do this. Okay, smash them together. The x's go away. 12y plus 3y is 15y. 10 minus 15 is negative 5. Okay, so we're always adding, and then just divide by 15. Like that. So y equals negative 1/3. What you'll find in general, and I'll put this up, if you start to do the substitution method and you start getting a bunch of fractions when you do that, like it's okay, but we don't like that. And when you see something like that, you might think, you know, the elimination method actually would have worked better here, and that's correct. Okay, so we have, I substituted it into 1. I guess I keep using 1, but once again, I'm telling you, you could also use 2 for this step. So you already got one variable, so just plug negative 1/3 into that first equation. 2x plus 6 times negative 1/3 equals 5. Which means that 2x minus 2 is 5, which means that 2x is 7. Which means that x is 7/2. Okay, so that is our solution point. X is 7/2, y is 1/3, or the ordered pair 7/2, 1/3. All right, so that, if anything, is the general rule. If the coefficients already match, use elimination. If you're trying to use substitution and you're getting a bunch of fractions, you can keep going with substitution, but it might have been quicker and easier to use elimination, like we just did, because we had to do a little bit of work up top with making them match, but once we did that again, it was pretty easy. It's pretty powerful. It's just like you smash them together, bam, you get y equals negative 1/3. Okay, one more. The first thing you'll notice, so we have 2x equals negative 5y minus 11 and 3x plus 2y equals 11. The first thing you'll probably notice is that they don't line up, right? Like we like them to. So if we tried substitution, well, we get a 5/2 and an 11/2. If we try to solve it for x, whatever, either way, you'd get some pretty fractionally stuff. So we're going to try to avoid that. So we can always do elimination. So the first thing is make them line up. So remember, standard form for a linear equation is ax plus by equals c. So by writing in standard form, I mean just make it look like all the other problems we've done in this section. Okay? But now we have another problem. So the coefficients matching up doesn't matter because you don't want to eliminate a coefficient. You want to eliminate, or not the constant part of it, the 11s. We want to eliminate one of the variables, but those don't match up. And you'll see now, okay, I guess if you technically multiply this by negative 3/2, you could get it to be like to eliminate the negative 3, but we don't really want to be multiplying things by fractions, although you totally can. I think it's easier just to multiply both of the equations by some different constant. So it's not going to be enough just to do one of them. We have to make a coefficient match. So generally, this is almost just kind of like least common multiples. Look at the x's. Just why not? It's the coefficient is 2 and 3. So the least common multiple of 2 and 3 is just 2 times 3, which is 6. So if we multiply the first equation by 3, this would be a 6x. If we multiply the second equation by -2, this would be a -6x. We're totally allowed to do that as long as anything we do to one side of the equation, we do to the other side. Again, not the only way to do that. You could have gotten these coefficients to be 10 and -10, and it would have worked. You would have gotten the same answer. So this is just the way I'm doing it. I'm taking equation 1, multiplying it by 3, taking equation 2, multiplying it by -2, so that the coefficients I get are 6 and -6. You could do it the other way around and have the coefficients be -6 and 6, and it would work fine. All right. Yep. So equation 1 becomes 3 times all that stuff, 2x plus 5y equals, don't forget to do the other side, 3 times -11. Equation 2 becomes -2 times 3x plus 2y, and then equals -2 times 11. So now clean that up, and once again, we'll kind of be back to where we were at the beginning. We'll have something that the coefficients just match already, and we can do elimination. There you go. We have 6x plus 15y equals -33. -6x minus 4y equals -22. Add those equations together. The 6x's will eliminate, and then whatever you're left over is just that. Okay, like that. So I like, you don't have to put the plus sign, but I like to do it just like with addition. Just draw the bar and then add them. So you get 11y equals -55. It's easy to get confused with the signs here. So you're adding -33 plus -22, so that's -55. So divide both sides by 11. And there you go. All right, and now we're back once again at the easy part. So take y equals -5. I would probably just go all the way back to the beginning, and you can go here or here. It's the same thing. And just plug y equals -5 into one of these things. It'll be the same no matter which one you do. I guess I used equation 2 just because I keep using equation 1, and I said you can use either one. So we're going to have 3x plus 2 times -5 equals 11. So that's going to be 3x is 21, which means x is 7. Which means as an ordered pair, your solution is 7, -5. Again, just always, if you're feeling really confident, you don't have to check anything, but it's nice to know that it's right. So go back to both of these original equations and plug in x is 7, y is -5. They will both be true. Okay, that's all. Thank you.